All right, somebody asked me about a question with vector equations of lines, and it's all in two dimensions. So the thing to keep in mind is that whatever you write in vectors should be the same as what you would do in regular algebra. They should denote all the same points as they go through. So we're given a line of x minus 3, I'll put that in parentheses, x minus 3 over 2 equals y plus 1 over, ooh, that's weird, equals, interesting. Okay, the formatting there is weird. We'll fix that. There we go. Equals y plus 1 over negative 3. Now, I'll explain how I could have pulled out this line just visually. What I would have noticed is that the point given is x equals 3 comma negative 1, and the direction vector is 2, negative 3, because those are the values there. And so I know that this is the point in terms of point slope form. Y plus 1 equals negative 3 over 2 times x minus 3. And I hope you can see how you could rearrange that equation to get that. I hope you can also see how we have here 0.3 comma negative 1, and that if I do a vector of 2 steps in the x direction, I have to go 3 steps in the y direction to get back down onto the line right there. So anyway, that's just sort of a reminder of what's going on there. So there's our picture. And we're also given a separate point that is not on the line. I'm going to have to zoom out a tiny bit to capture it. The other point that's not on the line is negative 3 comma 8. Let's just type it in, because why not let Desmos pop it right on the line for me rather than me drawing it by hand. Beautiful. So, enough points on the line. Excellent. I didn't expect that. Oh well. Okay. Find the vector equation that is parallel to the line L and passing through the point T. Well, that's the same darn equation. So you could respond somewhat cheekily that it is the same equation given. You could also write it like this. It's going to have the same direction vector. It's just going to pass through the point where x is negative 3 and where y is 8. And so as I put those direction values in there, you can see that what we're looking at is a form of the equation where we have x minus x1 over d1 equals y minus y1 over d2. So d1, d2 is your direction vector. It's like rise over run, but the x direction is on top, so it's a sort of run over rise the way it's written visually. And the x1, y1 is just any point along the line. So that's all it is. Now let's write it perpendicular to the line L. So perpendicular means that you have opposite reciprocal for your direction vectors. So I'm just going to take the same equation that I had here, and I'm going to do opposite reciprocal. So the 3 and the 2 are going to change places, and I'm going to change one of their signs. I'm not going to change both of their signs. If I change both of their signs, I haven't made it perpendicular. Let's show you that. So let's say I make this 3, and I make this negative 2. It's not perpendicular because I didn't change either of the signs. If I change only one of their signs, now it's perpendicular. If I change both of their signs, it's not perpendicular. It's actually the same as I had it just a second ago. So remember, opposite reciprocal means you flip the rise and the run, and you make the whole fraction positive or negative. You don't make both the top and the bottom positive or negative, because then you're keeping the value the same. So if you have a direction vector, then your perpendicular direction is negative d2 over d1, or d2 over negative d1. It is not making both of them negative, because that's the same direction as making them both positive. So we did parallel line, which was the same dang line. We did a perpendicular line, opposite reciprocal. And now the last thing we're asked to do is we are trying to find the equation of a line that passes through point P and also intersects with this line, passing through point T and the intersection between the line L and the line R. Great. Okay. So we have a new line. This is line L. We have a new line called R. And the way R is given to us is 1 plus 2 lambda times I plus 4 lambda minus 1 times J. So what that means is that the x values of R are given as 1 plus 2 lambda, and that the y values on line R are given to us as 4 lambda minus 1. Because both of those equations have lambda, I can solve x minus 1 over 2 is lambda. And here I can solve y plus 1 over 4 is lambda. And so then I know that the new line R, is setting these two things equal to each other. So if I wanted to visualize line R, I could type in x minus 1 over 2 equals y plus 1 over 4. But how would I find this point of intersection without using Desmos? So that's the question there. So I'm going to pretend I don't have this tool here. I'm going to backtrack a little bit more. What I know with line L is that I can undo this process in terms of any parameter. I like to use t. The book likes to use lambda, likes to use mu. So what I know is that x minus 3 over 2 is equal to t. Just like how I solved the R line for lambda, I'm going to unsolve the L line for t, telling me that x is equal to 2t plus 3. Similarly, y is equal to negative 3t minus 1. So now I can set those equal to each other. So I'm going to take my x value and set it equal to my x value here, obtaining 2t plus 3 equals 1 plus 2 lambda. So that means that 2t plus 2 is 2 lambda, or lambda is t plus 1. Now I'm going to take the y values, take this version of the y value, make it equal to this version of the y value. So negative 3t minus 1 equals 4 lambda minus 1. Let's see, I can get rid of the minus 1s, just add 1 to both sides. And then I know that lambda is t plus 1. So just slide that right in there. Let's see how this works. Negative 3t is 4t plus 1. Negative 3t is 4t plus 4. 7t plus 4, if I add 3t to both sides, is 0. So t is equal to negative 4/7. Lambda is equal to t plus 1. So add 1 to that, add 7/7, I get that. So based on these values here, and I really only needed one of them, I should be able to find the point of intersection. Okay, so let's just double check. Maybe I made a mistake. It's super easy to make a mistake on these vector problems. There's a lot of different letters flying around. So let's try it. If I take my t value for x, what's my t value? Negative 4/7. So times 2, I get negative 8 sevenths plus 3. So that's 21 sevenths. Negative 8 plus 21 is 13. So I'm guessing it's 13 over 7. Let's try the y value. Negative 3t. Negative 3 times negative 4 sevenths is 12 sevenths. Minus 1. Minus 12 minus 7 is 5 sevenths. Okay, now let's go down to the lambdas and see if the lambdas give us the same answer. 1 plus 2 lambda. 2 times 3 is 6. 6 plus 7 is 13. 13 sevenths. Feeling pretty good. Y is 4 lambda minus 1. 4 times 3 is 12. 12 minus 7 is 5. Beautiful. Let's click on this again. Let's click on our point of intersection again. And that looks to me like 13 sevenths and 5 sevenths. And so that's the point of intersection. Almost done. One last thing is then writing the line that passes through the point T and the intersection between the line L and the line R. Find a vector equation of the line that passes through the point T and the intersection between the line L and the line R. Well, interestingly enough, it's got to have the exact same direction vector. So really, answer number 1 works because that passes through T and the intersection. So I guess if I had really thought about how point T is on the line, I did not need to go through finding the actual point of intersection because it's going to be the same line, the red line that we started with again. But the benefit of knowing how to do the point of intersection is that now if the point is off the line, now I can find the equation that goes between point T off the line and this point of intersection just by finding the slope in your regular way and just writing it as a direction vector. So, yeah, part C's answer is just line L again, because line L is, of course, going to go through a point on the line, T, and another point on the line where L intersects R. But still useful to see how I solve for the point of intersection. So there you go. Ask questions, please let me know what was hard.